All right, class. So this is my first assignment for Max, where we're really getting into using Max to create sound, to create some music. And our first assignment here is to make a synthesizer. So we're going to do a really simple project where all we do is make something that generates sound using the MIDI keyboard. So before I start, I do want to cover again one of the basics about where the audio inputs and outputs are in Max. If we open our Max window, if you go up to the options menu, under audio status, you will find the ins and outs of Max. So you can see here we have an input driver, we have the output driver, or output devices, sorry. And these should be set to whatever. In the MIDI lab, they're going to be set to the Focusrite Scarlett, right? Or the Scarlett, I can't remember what it's called, the little red box on your table. That's how you make the headphones work. And that's what you need to use to basically create, or to hear what's coming out of the computer. Right now, the input doesn't matter. You could have this as none because we're not actually using any sort of microphone, but that could be something you change later. Just so you're aware, if you turn the audio driver on, which is pushing this button here, or as I mentioned, pushing this button down in the corner, in the bottom left, or bottom right, sorry, or the third way is when you have the Easy DAC on the screen, right? If this screen is locked, if I push this button, it's going to turn on the audio driver, right? Pushing that onto the speaker. So those are the three different ways of turning the audio driver on. And as you can see, there are some other things, the sample rate, the vector size. These are related to latency and stuff like that. You can use those. This is really important. It's something we'll talk about later in class, the audio scheduler and overdrive and the audio interrupt. But let's just start from here. Just again, we got to there through this menu right here, right? I go to options, I go to audio status, and then I can pull down this menu or open this menu, sorry, right? So let's get started with something simple. So we're going to make a simple synthesizer that uses the MIDI keyboard, all right? And what I need to do then is use some objects. So the first object I'm going to use is called the note in. And I'm going to use the note in to gather information from the MIDI keyboard, all right? So the first thing I do is hit N for new, right? And then I can type in note. As soon as I start typing, note in pops up. I can hit enter to select that and make the note in object, all right? And as you can see from note in has has one inlet at the top and three outlets at the bottom. And you can see the bottom outlets, if you mouse over them, it tells you what they do. The first outlet sends a note, all right? Now, if you didn't know, MIDI keyboards, so if I pull up the K slider, which is the MIDI keyboard, the MIDI keyboard that you have at your desk is sending what's called a MIDI number, all right? Instead of sending to the computer, for instance, G or F or B flat, it sends a number. Middle C is 60. E flat is 63. G is 67, for instance. An octave lower than C is 48, right? Because it's 12 notes away. So these are what are called MIDI numbers. So the physical keyboard in front of you is sending MIDI numbers into the note in, which I'm then going to pick up by the MIDI keyboard, okay? And let me show you again how to make the MIDI keyboard. So I hit N for new, and I type K slider. Because the MIDI keyboard is actually a type of what's called slider, right? And that's how I know what it is. And you use these things so much that you're going to find them. If I go to sliders as well, up here, I can go over to this one. The K slider is what gives you the physical keyboard on the screen, all right? So I can do several things. The first thing I want to do is connect the pitch from note in into the MIDI keyboard, all right? And all this is going to do is display the MIDI note that I play on the keyboard itself when I play notes. Now, sitting at my desk here, I don't actually have a MIDI keyboard. I should have gotten one out. But if I were to have one, I could play the MIDI keyboard and then it would show the notes here. It would show them like this as I played them. Okay? So in addition to that, we can use velocity. Now, we're not going to right now, but velocity is how hard the notes are hit. Okay? And I can use that number actually. We will use it later to generate a keyboard that's going to change sound, for instance, or change the duration of a note. Right now, we're creating a keyboard or a synthesizer that is literally going to do nothing but play a note constantly, all right, based on whatever I choose. Okay? So the first thing then is, again, if I connect an integer box, and I did that by hitting I, right? That opened the integer box or created an integer box. And that shows me the MIDI number as it comes out of the MIDI keyboard, all right? So if I want to make sound now, I have to send my MIDI note into a synthesizer of some kind, okay? And I'm going to build that synthesizer from scratch with oscillators, right? So if I use an oscillator is a object that is going to create sound, all right? And because all of these are oscillators, all oscillators are sound generators, they're all going to have a tilde after them to indicate that they are audio objects, all right? So the first one, the most common, is the cycle tilde. And that is going to generate a sine wave, okay? There's also the saw tilde, which you can imagine is going to create a saw wave form, all right? There's also the rectangle tilde, which is a rectangle pulse waveform. So these are three examples of different waveforms. They all have different sounds, all right? And what we're going to do here is just attach one of these straight on here to generate sound, okay? Now, we need something before we do this. And the reason is because this is a MIDI number, all right? The cycle object or any of these oscillators is not looking for a it's not looking for a MIDI number. It's looking for a frequency, all right? And we don't want to send out a MIDI number because if I connect this here, what I can tell you, first of all, is that G or A right here, this A is MIDI number 57, but the frequency is actually 440 hertz. So we need to convert these MIDI numbers into frequencies somehow so that the cycle object can play them correctly, right? Because right now the cycle object thinks I want to play the frequency of 57, which is not this note, okay? So I'm going to use a converter. So we have a simple converter in Max called the MIDI to frequency object. So N for new, and then MTOF. And what it does is you can see right at the top there, convert a MIDI note to a frequency. So if I connect my MIDI number to the frequency box, and then I'm going to use a float object by hitting F for float and connect that there, I can now hear this frequency, or I will hear this frequency when it comes out. Now when I play middle C, it was a different middle C. Not middle C, A. I picked the A low. It's 220, right? So the MIDI number 57 is being converted to a frequency, and this A is 220. I thought I was on the A above. That's why I said 440. So the A below middle C or above middle C is 440 hertz, okay? So if I now want to make this make sound, I need to connect it via cable, right? Now, remember that the cycle object is generating no sound because it's not connected to anything. So one of the first things you can do if things aren't working, if you're trying to troubleshoot, is to make sure that everything is connected via cable, all right? Now remember the rules about this. We're never going to connect a cycle object directly into the speaker. We need to control it with two objects, okay? The first, well, not objects, one of them is an object, the other one is the mute button. The first is a gain tilde, okay? And again, what that does is it creates a little volume controller that I can now insert below the cycle object, connect it to the inlet of the gain. And technically now I could run it out, right? And remember, MIDI signal cords or audio signal cords are dotted. That means there's an audio signal coming out of this object, okay? And I'm going to attach this to both the left and the right of this object here so that I'm going to hear it, okay? So, but again, I mentioned the mute button. So we're always going to implement the mute button. It's a requirement for every assignment you do in this class. So, as you remember, I shared that with you. So there's a patch called mute button. It's right here. I'm just going to grab it because I used it before. I unlock this by hitting Command E, right? Or if you're using a PC, it's Control E. I copy it with Command C to copy, and then I go over here. I can see this is locked, or sorry, it's unlocked. I'm going to hit Command V to paste, and there it is, okay? Now, what I'm going to do is grab this and slide it down a little bit and drop this in place right here, okay? Now, if I want to scoot all this over so I can see this better, I'm going to hit Command A to select everything and scoot it over. There we go. Now it's kind of in better space. Okay? So from here, I now need to connect my gain slider to the left inlet and the right inlet of my mute button, okay? And I'm going to do this by connecting his here and this to the right. Now remember, we have a mono signal coming out of this cycle object, right? It's mono. And so there's only one signal. So what I'm doing is I'm sending it to both left and right so that it comes out left and right. And then the outlets of the mute go in the left and the right speakers. All right? And now, if I turn this up, I should hear it.
Sometimes I do crazy shit too, like 240, and then I get super rhythmic, high, fast, right, stuff.
Wow,
Obviously,
I forgot I left this on.
240, but it allows me to access all.
This is still playing. So let me go back over here. So now I should hear this when I turn it up, okay? Now we have a signal coming into the cycle object that is 440 hertz. Now a really important thing to remember, if I haven't connected, if I have not connected the cycle object, or if I connect the cycle object like this, and then drop this here, connect this here, right now this cycle object does not have a frequency inside it, okay? I know it says 440 here, but I haven't like sent 440 into this cycle object because it's brand new, okay? So remember, you need to kind of institute or restate that sound so that you actually input a frequency into this cycle object, all right? And I can do that just by changing the notes and going back. Now all these numbers are flying into the cycle object, and I can go to 440, all right? Now, I locked this, Command E, and you can see the fonts kind of change, right? The inlets kind of disappear, and the boxes around the comments disappear, and that's how I know something's locked or not. And so now I can actually turn this volume up, right? And the last thing, of course, is that it's still muted. So when I unmute it, I can now play the MIDI keyboard. And I can play a melody on this piano. And what's happening, of course, is that those notes are going into the, they're going through here. The MIDI number is being converted into a frequency and then outputting here into this float box, which is then going into the cycle object, into the volume controller, and then outputting to the left and the right channels. Okay? Now remember, don't make the mistake of connecting, for instance, this cord to the left out or the right outlet of that, of the gain, right? The right outlet of the gain is nothing but the value of the gain slider, okay? So, and one of the most useful things to do is to know, if you want to know the value of the gain slider, if I connect a integer box, for instance, to the gain slider, I can see what the values are. It's actually between 0 and 157, okay? So you can see now those are the values going into the gain slider, so I could do something with that if I wanted to, right? For instance, what if I wanted to automate, have this changing by itself all the time, right? I could do something like this, Metro, new Metro 500. I'm going to give it a toggle by hitting T and then connecting that. And then I'm going to do a random 157, okay? Connect that there and then run this into here, okay? So now when I turn this metronome on, watch what's going to happen. Every 500 milliseconds, the volume controller is going to ramp or change values, okay? And that way, I could use this for all kinds of stuff. But that is an example of why it would be important to know what the value of that slider is so that my random object can make use of those values. Okay? So the next thing we're going to do here then is create an additive synthesizer, all right? So let me show you how this works. What I'm going to do is, I don't know if we've talked about this in class, but additive synthesis is one of the simplest ways of creating sound in music in the complex, like creating a complex tone. It's also one of the most fundamental techniques for generating more complex sounds is to literally take a bunch of sounds and add them together, okay? And that's exactly what we're going to do. So you can imagine my cycle object here can only create one sound. It can only generate a single frequency at a time. So, but imagine if I had lots of cycle objects, right? What if I have 4 or 5? I could now generate 5 tones at once, or 5 different frequencies that are kind of contributing to the larger sound, all right? So, and there are so many different ways of doing this. So first of all, if I wanted to, I could change the pitches of these, right? I don't want these all to be 440 or it's not going to be a complex tone. It's going to be just a louder cycle object with lots of sine waves at once being loud, okay? So instead, what I'm going to do is change the number coming out of here, all right? So let's do this. I'm going to drag this down here just so we have a box here every time so we can see what these frequencies are going to be. And in case you're wondering how I'm duplicating something, I'm holding down Option and dragging over, okay? I can hold down Option and drag anything to make another one of these. All right, so I'm going to connect all these here. And then what I'm going to do is take the frequency coming out of here and change it for the second one, all right? Now, one of the most common things to do is what's called the harmonic series. And so I'm going to take this frequency, multiply it by 2, and drive it in there. Then I'm going to multiply by 3 and connect it in here, all right? Multiply by 4, run it into there, multiply by 5, and run it into the last one, all right? Now, do not forget, these are not going to work, right? Watch this. When I connect this, only that first one's working, and the reason is I haven't cabled this together, right? So cables are everything in terms of making it make sound and working. Now you can see every time I play a note or 220 for instance, I get 440. 220 times 3 is 660. 220 times 4 is 880, and so forth and so on. All right. Now, if I run all these cycle objects into my gain slider, I'm now going to get a more complex sound that incorporates all 5 of these oscillators together into a complex tone here. Okay? Now, one thing I have to be careful of is obviously it's going to be louder because I have 5 oscillators now instead of 1. So I just need to be careful about the volume. All right? So let me turn this down a little bit and then unmute, Shift M, and now you can hear my tone. Okay? So you can hear the sound now is kind of is always, it's a little bit brighter and a little square in sound, and that's because it's 5 oscillators now instead of 1, right? And we could go up the whole harmonic series. So the harmonic series is a really cool thing. Let's actually just go up 5, 6, 7, 8, and 9. Let's just go up to 9. Normally the harmonic series goes up to 11, but we're just going to go to 9. All right. Now, the nice thing too is if I hold down Shift while clicking this, watch what I can do. I can make lots of cables without having to drag from the beginning over and over each time. All right. Same thing here. I can actually click on the outlet and click on the cycle object each time to make more cables. And now you can see I have all these cables going to there. So let's hear what this sounds like now. Now that we've added all these instituted all these extra 4 more sounds. All right. Unmute. So first of all, you can hear we're hearing the initial sound here because these 4 have not received a frequency yet. These 4, right? They don't have a frequency. They're still at 0 because they have not had a calculation yet. Listen though, as soon as I hit a note, I'm going to re-hit D. Now these 4 are also contributing. Okay? And we hear this synthesizer now coming out. So this is essentially your first assignment. Okay? Now you can do more with this if we want to think about some other cool things that we could do. One of them would be to make it so the sound is always changing. And one way of doing that is actually, if you think about it, if every one of these had their own volume controllers, I could go through here and manipulate the sound every time. I could change the sound. Maybe I make it like this, right? But I have to figure out how the chords are going to connect to those individual cycle objects, right, to make that happen. And then, of course, every one of these has to go left and right, left and right, left and right. You can see how, it does get messy with the cabling. It can get very hairy with cabling, so it's something to keep in mind. That's a natural part of Max, is that, it can turn into a very complex patch with a lot of moving parts and a lot of things to connect and disconnect. Okay? Anyway, so that is creating a simple additive synthesizer. And, from here on Thursday, we're going to make this more intricate. Okay? So, yeah, we'll go from there.